In this video, we'll look at a few conceptual problems on multiplication of matrices. Here are 5 matrices and here are their orders. So the matrices are X, Y, Z, W and P. And their orders are, the order of X is 2 by n. This means X has 2 rows and n columns. The order of Y is 3 by k. The order of Z is 2 by p. Order of W is n by 3. And order of P is P by K. There are variables in all of these orders. Now the question is, what is the restriction on these variables on N, K and P such that this matrix Py plus Wy is defined? Pause the video, think about it. Okay, so for Py plus Wy to be defined, these two matrices independently have to be defined. This product should be defined, which means Py is defined. Then we have Wy, this should be defined. And it's not enough for both of them to be defined. Their sum should also be defined. That's what we are asked. What is the restriction such that their sum is defined? So how do we do this? Let's talk about the products first. When we're multiplying two matrices, let's say we multiply A and B to get C, this is how their orders work. First of all, the number of columns of A should match the number of rows of P. Only then their product is defined. So if the order of A is P by Q, if it has Q columns, then B should have Q rows. If this is not the case, then you can't multiply. Then the multiplication is not valid. So this is P by Q and this is Q by R. Now when you multiply, you get C with order P by R. Number of rows of C match the number of rows of this first matrix, A, this is P, and number of columns of C match the number of columns of this second matrix, so this is R. So if A is P by Q and B is Q by R, their multiplication is defined. And when you multiply, you get C with order P by R. So let's use this to figure out what is the restriction on N, K and P for Py to be defined. Let's see, where's P? P is here. Order of P is P by K. And Y is here. The order of Y is 3 by K. For this product to be defined, the columns of P should match the rows of Y. Let's write this down. Number of columns of P should match the number of rows of Y. So here we have K and here we have 3. This means we get K is equal to 3. When K is equal to 3, this product is defined. Py is defined. And what's the order of this product? The order comes from the number of rows of P and number of columns of Y. Rows of the first matrix and column of the second matrix. So the order of Py, that's going to be P by K. So the order of Py is P by K. And if K is 3, this order is P by 3. So the order of Py is P by 3. Let's move on. We have Wy. We also have to make sure that this is defined. So Wy is defined when the columns of W match the rows of Y. So 3 matches 3. Well, that's always the case. So we got nothing new here. Number of columns of W should match number of rows of Y. This is true because 3 is equal to 3. But what's the order of Wy? For the order of Wy, for the order of this product, we take the rows of W and the columns of Y. So the order of Wy, that's N by K. So that's N by K. And when K is equals to 3, the order is N by 3. So we have the order of Py and we have the order of Wy. Now let's look at their sum, Py plus Wy. This is defined when both of these matrices are of the same order. You can only add matrices which have the same order. So this should match this. Order of Py should match order of Wy, which means N by 3 should match P by 3. This part matches. This part should also match. This means P is equal to N. Now these are the restrictions. K should be equal to 3 and P should be equal to N. These are the restrictions on N, K and P for this matrix to be defined, Py plus Wy. Here's the second part. If N is equal to P, what is the order of the matrix 7x minus 5z? Now pause the video, try this out. Okay, let's do this together. Let's look at X and Z. If N is equal to P, the order of X is 2 by N and the order of Z, that's 2 by P, but N is equal to P, so that's also 2 by N. So both of them have the same order, that's 2 by N. Now let's look at 7x minus 5z. If you multiply by a scalar, the order does not change. So the order of 7x remains the same, that's 2 by N. Same thing is true for 5z. The order of 5z, that's also 2 by N. And if you add or subtract, you're adding or subtracting matrices of the same order. The resultant will also be of the same order. So the order of 7x minus 5z, that's also equal to 2 by N.